All right, for this one, what threw me off was the 12 kilometers per hour, okay, getting into 3.33, because the step wasn't shown in the PowerPoint. Okay, so I got that ready for you. So what you need to do, and something we haven't talked about yet, is called item analysis, unit analysis. Okay, so it's a way to help you with conversions. Okay, so with our kinetic energy, we're not supposed to put our speed in kilometers per hour. Okay, we need that in meters per second. Okay, because that's how we do it. So we need to convert that. And how you do it is you put 12 kilometers like this per 1 hour. And some people can do it in their heads, but I'm not one of them. Okay, so I need to take it apart one item at a time. So I picked the kilometers first that I wanted to get rid of, and I wanted to find out how many meters that was. Okay, so to be able to cancel out your kilometers, that needs to go on the bottom, because one, kilometer divided by kilometer is 1, right? So those cancel each other out. Okay, so how many meters are in 1 kilometer is 1,000. Okay, so you're going to end up timesing this by 1,000. Then I decided I wanted to get rid of the hours. So meters I'm happy with. Okay, yay. Put a little smiley face. Okay, now I don't want hours. I want seconds. I want to get rid of hours. Okay, so I put that on the top up here. And then I think, how many minutes are in an hour? 60. Okay, then I can cancel out my hours, and I have minutes. I still don't like minutes though. Okay, I need seconds. So how many minutes, or how many seconds are in a minute? Okay, so I put a minute up here, so I could cancel that out, and then I have 60. Okay, so to punch that in a calculator, okay, what I do is I go $12 times 1,000. Okay, divided by 60 times 60 is 3,600. Okay, and that's where we get our 3.3 repeating. Okay, so this speed, it needs to be in seconds, right? We're happy with seconds. Okay, so we need to put, for step 3, punching in our numbers. Okay, and let's just go like this. No, like this. Too big. Okay, which is mass was 87 times 12, or why did I put 12? Okay, this is our new number here. Okay, we needed to put right here, okay, our new speed, okay, in meters per second was 3.3 repeating meters per second, so that's what we're putting here. Okay, and remember, we leave that number in our calculator, okay, and we need to square it. So if you want to write that in 2 separate steps, you can. Okay, that's what I'm going to do. Okay, so I'm going to put 3.33333 squared. That's this button on my calculator. Okay, and it's 11.111111. Okay, I'll just put repeating. And that's in meters per second, which is good. We like meters per second. Okay, now I'm going to put that times that divided by 2. Okay, or times 0.5, whatever. Works out the same. Okay, is 483.333. Okay, to 3 significant digits. Okay, now let's check that with the PowerPoint and see if we did it right. And if we did it wrong, that's okay. We'll just find out our error. Okay, 483. I had 482. Okay, did I type it in wrong somewhere? Let's find out. Okay, 87 times 0.5. Maybe we should put maybe I think their answer is wrong. That's what I think. Okay, because they're 3.333. They rounded that early. Okay, and I don't think they should have. Okay, they put 3.333 and they got 11.0089. Okay, where it should be 11.111111. So don't round along the way. Otherwise you get a slightly wrong answer. Okay, so let me come back here. Right, so this is talking about how mass increases, kinetic energy increases, which makes sense. Okay, something that's heavy, you chuck a watermelon off a bridge, okay, that's going to go a lot faster than throwing a grape off a bridge. Okay, is the idea. Okay, so if you're taking this ball, pushing it at a speed of 20 meters per second, okay, let's do that. Let's list our variables. Okay, mass 2.6 kilograms, speed 20 meters per second. Okay, what's kinetic energy? And they put the answers, but it doesn't show the work. Okay, so let's put our work. So this was our mass. Okay, this was our speed. Okay, and I feel like I always need to do all this work because otherwise I'm going to get it wrong again. Remember how I didn't square my speed at first? Okay, really important. Okay, so I'm going to do the squared first because in BEDMAS it says I'm supposed to do exponents first. Okay, put a reflection rate times 0.6 times 0.5. Okay, 120. Okay, and let's see if that's what they put in the PowerPoint too. Yay. Okay, we got that one right, and let's put it in a box. Okay, because we don't want to miss the squared part. Okay, this is showing you what happens to kinetic energy if speed increases. Okay, so in the last question we had 20 meters per second, and this one we have 24 kilometers per hour. Okay, so we could do item analysis again. Why not? Let's do it. Okay, let me get another piece of paper for you. Okay, where mass is 87. Speed is 24. Okay, and let's figure it out. Okay, because it's not showing our work here. So let's do it. Okay, our mass was 87 kilograms. Speed 24 kilometers per hour. We don't want kilometers per hour. Okay, and let's write it tidily. Okay, so let's turn that into meters per second. Okay, because we don't like it in kilometers per hour when we're doing potential energy and kinetic energy. Okay. So it doesn't really matter when you put your formula, okay, as long as you do. So let's figure out how many meters per second that is. Okay, so there's 24 kilometers in 1 hour. Which one do you want to get rid of first? Hours this time? Sure. Okay, so in every hour, there's 60 minutes. Okay, so we can cancel those out. In every minute, okay, there's 60 seconds. We can cancel those out, but we still have kilometers. We don't want kilometers. Okay, so let's put in every kilometer, there's 1,000 meters. So let's punch that in. 24 times 1,000 divided by 3,600 is 6.6 repeating. Okay, let's put that in our formula now. Hello, doggy. Okay, and then, I'm going to put it in red. Okay, just to force myself to remember this exponent. Okay, so I'm going to take my answer, leave it in the calculator, push my exponent button. Okay, and then I'm going to multiply that by 87, 9.5. Okay, and get 19,193. What was it? 1933.3 repeating, but we don't like that. We want significant digits, 1, 2, 3. They seem to like that one for these questions. Okay, so I'm going to put that in scientific notation. 1, 2, 3. That's how I get 10 to the 3 joules. Okay, and they got the same, but they didn't put it in scientific notation, which they should have, right? Okay, next up is just using the different versions of the formula. Okay, so they look more complicated. Okay, so rearranging the formula for mass, you end up with this one that we wrote down. Okay, rearranging for speed, you end up with this one. So it's good to do practice questions using this, just so we have punched in those kinds of equations before. Okay, let's go to our sample and see if we can do it in 3 minutes. Okay, so let's list our variables. They gave us 14.2 meters per second. Kinetic energy is 950. What's the mass? In kilograms. Okay, so let's try to do that on our own, and then we will look at the answers. That was speed. Step 2. Okay, what was our formula? We forgot already. That's okay. Mass is 2 times kinetic energy divided by v squared. Plug in our numbers. Okay, putting the squared with a little red exponent, because if we forgot it once, we might forget it again someday. Okay, so I'm going to do that first because that's what I like to do, but you don't have to. So 14.2 squared. Okay, and then 2 times 950 divided by 201.64. Okay, 9.4, blah, blah, blah. And 3 significant digits, 9.42 kilograms. Okay, let's check. 9.42, hooray. Okay, and we won't have time for the next one, but we will try it anyway.